actually involves doing work, yeah. Temperature and heat. So temperature and heat are related, but they are not the same thing. Temperature is a measure of the random motions of the components of a substance. So if we look at this box, I mean, who puts hot and cold water in a box? I don't know. On this side, we have hot water, and on this side, we have cold water. Why is something hot or cold? Have you ever thought about that? You put some water on the stove and you heat it up. Why is it hot? You put water in the refrigerator and it gets cold. Why? What's the difference? It's still water, right? And the air temperature goes up and down, and sometimes it goes, really crazy, 40, 50 degree change in a day. What's the difference between the temperature? What makes it a different temperature? It has to do with the motions of the molecules and atoms. So in hot water, the water molecules are moving faster. In cold water, they're moving slower. All matter is moving. Okay, we talked about states of matter. Right now you guys are in the solid state. You're all sitting in your chairs and you're not moving very much, just fidgeting a little bit, erasing, looking out the window at the truck going by. You're just moving a little bit. You're breathing, that's a good thing, keep breathing. But you're not moving very much. When class is over though, you guys get up and you go out the door and you go off in all different directions and you're walking and you're moving much faster, aren't you? So the particles in matter move also. In a solid, the particles vibrate, they fidget, they're moving like you guys are moving right now. In a liquid, they're moving faster. They're actually changing position relative to each other. And in a gas, they're going just in completely random directions and completely independent of each other, and they're moving faster. So hot water, the particles are moving faster, and in cold water, they're moving slower. And it is this motion that causes temperature. Temperature is a measure of the kinetic thermal energy of a substance. So let's think about Reedley Beach, right? That's a sore subject for some people. Oh yeah, come to Reedley College, we've got a beach. Right? This is like the town joke. We do have a beach. It's just on a river, but there's lots of sand. And people go there in the summer because there's nowhere else to go, right? We don't even have a pool right now. But imagine going to Reedley Beach. Middle of August, it's 110, and you want to get to the cold water, but you have to walk across the sand. Ouch. Exactly. Are you just going to stroll casually barefoot to the water? No, you're going to hot-foot it to the water, right? You're going to run because it hurts. On hot sand, barefoot people move fast because it's painful, right? So hot matter moves quickly. Let's say we go to Pismo, to a real beach, and here it's still 110 in the middle of August, and there it's like 65 and windy and foggy, which is why we go to Pismo in the summer. And the sand is wet because it's low tide. You're barefoot. Do you need to run quickly to the water? No, you can just stroll as slowly as you want to because the sand is nice and cool. So cool substances moving slowly. Hot substances are moving fast. We don't see the motion of the particles. The atoms and molecules are far too small for us to see, but they are moving, and we have a lot of scientific evidence that this is going on. So temperature is a measure of the motions of the components of a substance. How is that related to heat? Well, we know from experience that if you put a hot object next to a cold object, the heat from the hot object is going to transfer to the cold object. The hot one cools down, the cold one warms up until they end up at the same temperature. How does that happen? Heat is a flow of energy, a movement of energy from one substance to another based on the temperature difference. Heat is the way thermal energy is transferred. So these particles are moving quickly and they can transfer that energy to the cold molecules. The cold molecules are going to start moving faster. The hot molecules will slow down until they reach the same temperature. Does that make sense? Any questions?